In this section, we will be solving linear inequalities. Now, if you look at the steps for solving linear inequalities, you'll notice that they are very, very similar to those for solving linear equations. Very similar. In fact, there's only one very important exception. If you ever multiply or divide both sides of an inequality by a negative number, you have to reverse or switch the inequality sign. That means if you have a less than symbol, you have to replace it with a greater than symbol, and vice versa. If you have a less than or equal to symbol, you have to replace it with a greater than or equal to symbol, and vice versa. That's what we mean by reversing the inequality sign. And to kind of show you why this is important, I'm just going to take a little example here. -1 is less than 5. All right, looking at this, you can see that it is true. -1 is less than 5. Let's see what happens when we multiply both sides by a positive number. I'm just going to pick 2. So -1 times 2 is less than, same thing on the other side, 5 times 2. Working this out, -1 times 2 is -2 is less than 5 times 2 is 10. So looking at this last inequality here, -2 is less than 10. So that works. That's fine. Now let's try multiplying both sides by a negative number. I'm going to recopy the same inequality here. -1 is less than 5. But this time I'm going to multiply both sides by a -2. So -1 times -2 is less than 5 times -2. Working out both sides, on the left we have -1 times a -2 is a +2, is less than 5 times a -2 is a -10. Now looking at this, 2 is not less than -10. In fact, 2 is greater than -10. This fact, this right here, is what makes it so imperative that you switch the inequality sign whenever you multiply both sides by a negative number. And the same is true for division. The same can be shown for division. So that's the one thing you really need to keep in mind as we work through these. Apart from that, it's going to be exactly the same as solving equations. So looking at example 1, we have 3x is greater than x plus 6. So to solve this, I'm going to gather all of the x terms on one side of the inequality sign. And same as before, you could go either direction, but I'm going to subtract x from both sides. 3x minus x gives us 2x, copying down the greater than symbol. X minus x gives us 0, so it goes away and leaves us with 6 on the right. Now, still solving for x, I'm going to divide both sides by 2. On the left, the 2's cancel out, give us 1x, or just x. Now, notice we divided by a +2. So in this case, we do not need to flip the inequality sign. We can just leave it as it is. On the right-hand side, 6 divided by 2 is 3. So our answer as an inequality is x is greater than 3. Now we're also asked to graph the solution on a number line and write it in interval notation. So here on the number line, I'm just going to start with my solution. There's 3, and I'm going to plot a number on either side. That's really all you need to do. Now the solution set for this, x is greater than 3, means x can be any number provided that it is greater than 3. So on the number line, x could be 4, it could be 3.5, it could be 100, it could be anything so long as it is greater than 3. So on the number line, I'm going to shade everything to the right of 3, all the way. I'm going to darken this arrow here as well to positive infinity. Now on the graph, you also have to indicate whether or not you actually include 3. Here, because we have x is strictly greater than 3, we do not. So we use a parenthesis here. And that is the graph of this solution set. Writing this in interval notation, we're going from 3 to positive infinity. We never include positive infinity, so a parenthesis goes there. And because it is strictly greater than, we don't include the 3 either. So there is our answer written in interval notation. Example 2, same idea. We have 3 minus 5a is less than or equal to 2 times a plus 5. Removing the parentheses by using the distributive property. I'm just going to copy down the left-hand side here. 3 minus 5a is less than or equal to 2 times a is 2a, 2 times 5 is 10. Now solve. I'm going to subtract 2a from both sides. So over here on the left, I have 3 minus 7a is less than or equal to 2a minus 2a equals 0. So on the right-hand side, I'm left with 10. Subtracting 3 from both sides. On the left, I'm left with just negative 7a is less than or equal to 10 minus 3 is 7. Divide both sides by negative 7. And on the left, we have 1a, or just a. On the right, we have 7 divided by negative 7 gives us negative 1. Now notice what we did here. We divided both sides by a negative 7. So that means we have to reverse the inequality sign. So instead of less than or equal to, it's going to be greater than or equal to. Whenever you divide both sides by a negative number, you have to reverse that inequality sign. Otherwise, your answer will be incorrect. Now on the number line, I'm going to go ahead and plot the negative 1 and just something on either side. There's negative 2, there's 0. And looking at this, a is greater than or equal to negative 1. So a can be 0, it could be 2, it could be 5, it could be anything that is greater than negative 1. So I'm going to go ahead and shade all the way from negative 1 and then darken the arrow so that you can see it goes to positive infinity. Now notice here we are including the negative 1. So instead of a parenthesis, you want to put a square bracket at the negative 1. Writing this in interval notation, we're going from negative 1 all the way to positive infinity. Never include positive infinity, but you are in this case including the negative 1. So there's your square bracket and there's your answer in interval notation. Now the last one here, example 3, we're going to first need to remove the parentheses. So I'm going to distribute the negative 5 into this first set of parentheses. Negative 5 times x gives us negative 5x. Negative 5 times 2, there's minus 10. Copying down the inequality symbol. Do the same thing on the right with the negative 3. Negative 3 times x is negative 3x. Negative 3 times 4, there's your minus 12. Now gather all the x terms to one side of the inequality sign. I'm going to add 3x, add 3x. Negative 5x plus 3x gives us negative 2x minus 10 is greater than or equal to. Negative 3x plus 3x gives us 0. So we're left with just a negative 12 on the right. Adding 10 to both sides. On the left-hand side, now we just have negative 2x greater than or equal to. Negative 12 plus 10 gives us negative 2. Divide both sides by a negative 2. And on the left, the negative 2's give us 1x, or just x. On the right, negative 2 divided by negative 2 is a positive 1. Again, we divided by a negative number. So instead of greater than or equal to, it switches to less than or equal to. You have to switch the sign. Don't forget to do that. Box in your answer. And now graph on the number lines. So here the endpoint is 1. So there's 1. I'm going to go ahead and plot 0, 2, and There's room here I can squeeze in a 3 and a negative 1. And at 1, you're going to want to have a square bracket. And looking at this inequality, we have x is less than or equal to 1. So x can be 0, it can be negative 1, negative 2, negative 80. It can be anything all the way down to or toward negative infinity. So you want to be sure to shade that entire arrow. And you can't include 1s, so there is the square bracket at 1. In interval notation, you're going from negative infinity to 1. Can't include negative infinity, but you do include 1. So there's your square bracket at 1.